Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0641, signifies that there is a malfunction in the sensor reference voltage A circuit, which is crucial for various components to function properly. This code indicates that the engine control unit, ECU, is not receiving the correct voltage levels from the sensors it utilizes for operation. The affected components generally include the manifold absolute pressure (MAP) sensor, the fuel rail pressure sensor, the continuously variable transmission (CVT) drive pulley speed sensor, the accelerator pedal position (APP) sensor, the AC pressure sensor, and the fuel tank pressure (FTP) sensor for US models. These components are typically located within the engine bay, often mounted on or around the intake manifold or fuel rail area, where they can monitor relevant pressures and positions critical to vehicle performance. Understanding the role of each sensor in providing accurate feedback to the ECU is vital for diagnosis. These sensors help ensure optimal engine performance by regulating fuel and air mixtures, providing critical data for transmission shifts, and managing HVAC operations. DTC P0641 indicates a malfunction in the sensor reference voltage A circuit, which supports vital sensors like the MAP and APP sensors responsible for various engine functions. When this code appears, it signifies that the engine control module, ECM, is not receiving the required voltage for these sensors to function accurately. The sensors impacted by this DTC play essential roles in performance. For instance, the MAP sensor measures manifold air pressure, allowing the ECU to adjust fuel delivery accordingly. And the APP sensor feedback is critical for throttle position adjustments. This DTC generally emerges during vehicle diagnostics through the Honda Diagnostic System, HDS, confirming that the ECU is not operating as intended. The precise diagnosis begins with confirming whether the DTC persists through preliminary checks of the system's operational status. Several potential causes could trigger DTC P0641, making this an essential focus during diagnosis. The first possibility involves faulty sensors, which can lead to incorrect voltage readings being sent to the ECU. Another cause could be poor connections or loose wiring, especially within the voltage common collector (VCC) lines. These lines distribute critically power to the sensors. Furthermore, a defective powertrain control module (PCM) could also be at fault, as this is the central unit managing sensor inputs. Each of these elements must be thoroughly examined, as they may contribute to the observed voltage malfunction. Therefore, understanding and exploring these components during troubleshooting is vital to restore proper vehicle diagnostics. Symptoms associated with DTC P0641 may include an illuminated check engine light, signaling a fault in your vehicle system that requires attention. Drivers might also experience poor engine performance, as the engine may not run optimally due to incorrect sensor feedback. Stalling or hesitation during acceleration could indicate that the engine is receiving inconsistent or inaccurate data, leading to undesirable performance. Additionally, the vehicle may struggle with fuel efficiency due to automatic adjustments not functioning correctly because of the malfunctioning sensors. Recognizing these symptoms is important to ensure timely diagnostics and repairs, helping to maintain vehicle performance standards. The first step in troubleshooting DTC P0641 involves switching the vehicle to the on mode, which powers the electronic systems, allowing for diagnostics to occur. Next, clear the DTC using the Honda Diagnostic System, HDS. This procedure removes previous codes to determine whether the issue is intermittent or persistent. Following this action, you should check for any pending or confirmed DTCs using the HDS again. If DTC P0641 is still indicated, it confirms a persistent fault that needs further investigation. However, if no DTC appears, it may suggest an intermittent failure, indicating that further checks for poor connections or loose terminals at the powertrain control module, PCM, may be necessary to understand the underlying issue. In the second troubleshooting step, first switch the vehicle to the off or lock mode to ensure safety while handling electrical components. Once off, disconnect the connectors for specific sensors, including the MAP, fuel rail pressure, CVT drive pulley speed, APP, AC pressure, and FTP sensor for US models. It's crucial to properly handle these connectors to avoid causing damage. After disconnecting, turn the vehicle back to the on mode. This will allow the ECU to run diagnostics without the input from the disconnected sensors. Once again, utilize the HDS to clear and check for DTCs. If DTC P0641 is indicated at this point, it suggests a deeper issue, potentially with one of the disconnected sensors or their connections. Step 3 revolves around reconnecting the previously disconnected sensors one at a time, while observing the behavior of the vehicle's diagnostic system. This allows for targeted identification of which specific sensor is causing the DTC P0641 to reappear. For each reconnection, ensure to check for pending or confirmed DTCs using the HDS. This system will alert you to any immediate issues related to the specific sensor being reconnected. If DTC P0641 activates again after reconnecting a certain sensor, it highlights that the sensor or its connection is likely defective and needs replacement. Conversely, if the DTC does not reappear, proceed to inspect for loose connections or other related wiring issues, as the root cause may not solely lie within the reconnected sensors. In this fourth troubleshooting step, begin by switching the vehicle to the off or lock mode again. Next, jump the SCS service check switch line with the HDS, which sets the vehicle in a troubleshooting state that allows for more comprehensive testing. It's essential to wait over 1 minute after jumping the SCS line before moving on to the next steps to ensure accurate readings. Subsequently, disconnect the PCM connectors, specifically Connector A, 51P, and Connector C, 51P. After disconnection, turn the vehicle back to the on mode and measure the voltage between the designated test points and body ground separately for each disconnected component. If you find voltage readings at these points, it indicates a short-to-power issue in the VCC wiring between the PCM and the disconnected components that must be addressed. The final troubleshooting step begins by ensuring the vehicle is turned to off mode once more. You will then check for continuity between specific test points for the sensors previously disconnected, testing each one against body ground. This step is essential to ensure that there's no unwanted short circuit present within the VCC lines, which would influence the sensor's operation. It's important to ensure that if continuity exists where it shouldn't, it indicates a short in the wiring that requires repair. If there is no continuity, the wiring might be intact, but further investigation is indicated. In this case, examine any service information regarding the DTCs or symptoms, and if necessary, substitute with a known good PCM to isolate the issue completely. After completing the necessary repairs based on the prior steps, it's crucial to verify that the problem is truly resolved. Begin this process by clearing the DTC with the Honda Diagnostic System, HDS, once again, ensuring that any residual codes are removed from the system. After clearing, conduct a thorough test drive to simulate normal vehicle conditions and check if the DTC reappears during operation. During this drive, Monitor vehicle performance for any signs of hesitation or engine issues that could indicate incomplete repairs. It's vital to ensure that all sensors are working correctly and that the expected voltage levels are achieved. If the DTC does not reappear, it confirms the resolution of the underlying issue, ensuring optimal vehicle functioning. To mitigate the risk of encountering DTC P0641 in the future, regular preventive maintenance practices should be instituted. This includes performing routine inspections of critical engine components and sensors, ensuring they are free from corrosion or damage. Ensuring that electrical connections are secure and that wiring remains intact is vital to prevent shorts or poor connections. Additionally, periodic checks of diagnostic trouble codes, DTCs, can catch potential issues before they escalate into more significant problems. Regular vehicle servicing, alongside these practices, can provide a greater assurance that the various components, especially the sensors involved, remain in good working order, extending their lifespan and preventing unexpected failures. DTC P0641 highlights the importance of monitoring sensor reference voltages within the vehicle's diagnostic system. A malfunction in this area can lead to a cascade of performance issues if not addressed promptly. Through methodical troubleshooting steps outlined earlier, technicians can isolate the root cause of the DTC, leading to effective repairs that restore proper function. Additionally, establishing preventive measures reinforces the reliability of these critical components, thus avoiding future issues. Keeping on top of diagnostics and vehicle maintenance is key to ensuring that the Honda CRV continues to perform efficiently while helping drivers maintain peace of mind on the road. Please like and subscribe to the channel. See you next time.